ChatGPT and GenAI tools have hit the mainstream. The chatter was everywhere, by almost everyone. We feel the discussion has been more philosophical than practical. We know enterprise technologists are using real AI to create efficiencies that result in real business outcomes. So, we created a show to talk to real practitioners about real-world active projects that are leveraging this exciting new technical advantage. Welcome to LiveAI.
Welcome to LiveAI, the show that discusses real-life use cases. We have quite a treat in store for you all because our guest has been called the father of the virtual assistant. He's spoken at TED and TEDx and was Inc. Magazine Entrepreneur of the Year. Welcome to the show, Kevin Surace, Chairman and CTO of AppVance. Welcome to the show, Kevin.
Yeah, thanks for having me. Super excited to be here. It's going to be a fun conversation.
Yeah, for sure. You know, I think it's important to let our audience know you earned your moniker for the work you did in the creation of OnStar, the voice assistant back in the day. People overuse the word game changer, but let's be honest, that really was a game changer.
Look, we had this vision in the mid-'90s, and this was at a company called General Magic, good-sized public company in Silicon Valley at the time. And so just terrific people there. And the vision was this, is cell phones, not smartphones, but cell phones were really just becoming popular for people. And that was Motorola flip phones and things like that. And at the same time, we're talking about 95, 96, 97, the internet is becoming popular, is becoming used. Email is finally showing up, right? All of these things are showing up, and calendars are now finally connected in some way. All of that happened within a few years. Except we'd get in our car and drive and we had no access to our calendar, our contacts, our email, nothing. And so out of misery comes a solution, right? Which was, why don't we use voice? Why don't we make this work so that you could connect the number automatically on your cell phone that would come up through your Bluetooth, which we did have in your car. And then you could interconnect and talk to a personal assistant, a virtual assistant. And so we invented the first virtual assistant. Her name was Mary, actually. It went by many, many names commercially. Portico, MyTalk, Magic Talk, the Quest virtual assistant, OnStar virtual advisor, all of those came out of the same set of servers. In those days, there's no cloud. So we literally built the servers, literally built them board by board, sliding them into racks in a center in Sunnyvale, California at the time. And so we built the first virtual assistant. We had a few dozen patents out of that work. All those patents eventually got licensed to Apple and Amazon and everyone else who made Alexa and Siri and everything else, because that was the basis of how you would form this human interaction with Mary, who was not human, but seemed awfully human.
Yeah. No, it's interesting to see how all that work turned into the things that, followed it. There's a person who was one of the founders of Siri, who's a friend of the show and friend of the company as well, and has spoken many times. And, that was really based upon the back of the work that you did foundationally that, created this whole thing in motion.
It was. In fact, the way they, with all due respect to them, right, the way they built Siri was literally pick up our patents and do exactly what the patents say. That's how all those systems were built, because there were a number of tricks that we used. I won't get into all of them because it'll bore people today, but it was about getting people into domains and thinking in domains so that at any one time we wouldn't have to understand the entire English language. We only have to understand maybe 5,000 things someone would say, and that would bring our recognition rates up because we don't have the unlimited compute horsepower we do today. So everyone used that, but that was patented. Putting people in domains was patented. The kinds of responses and randomized responses, we're the first people to have a randomized response, right? So that, you have all these different things in patents. You have vectorizing, right? Literally, we put things in vectors today, but we literally would put things in vectors and send them to the network as vectors and then send them back from some of our systems. So, and that's because we had the horsepower to create a vector representation of what was said, but we didn't have the horsepower to really understand it all on the device. So all of these things had been patented in the mid-'90s. So by the time you had things like Siri start to develop 8 years later, and Tell Me and a whole bunch of these companies, there were about 5 of them that came out. They just went right to the General Magic patents and said, well, this is how you do it. Because we laid it out. You have to teach in a patent how to do it. And of course, the patent holder at that time was not General Magic anymore. They were bought by Intellectual Ventures. Intellectual Ventures is run by Nathan Myhrvold. And Nathan Myhrvold used to be the CTO at Microsoft. So he bought all those patents knowing that voice user interface would be the way you'd go forward. And he didn't bother any of the startups. Like, he didn't knock on Siri's door and say, give me money. They're a startup. They don't have any money. But once Apple got involved, or Apple bought Siri, and AT&T or Microsoft, I think, bought Tell Me, and then Amazon worked on Alexa, then he knocked on those doors and said, hi, here's all these patents. And you read on all of them, right? You just, and look, everyone copies other people's work. So, I mean, we all learn from other people. So there's nothing wrong with this. I mean, I want listeners to say, I can't believe someone, look, yes, that's what we do. We learn from what other people did. And in some cases you go, what's the chance of getting sued? And so you basically do what the patent does. But in most cases you try to say, how do I design around this? These were pretty fundamental patents. It was not possible to design around them at the time. And so in the end, when the companies got sold, Apple paid hundreds of millions of dollars to license those patents. I know the number. It's a really big number. Yeah.
Yeah.
They paid more for the patents than they paid for Siri, the company. And Apple didn't know that those patents existed until, there was a knock on the door that said, hi, I'm here. These guys did everything, just did what reads on these patents. So that's not to take anything away from, the nice work that was done at all of these companies. But in the end, it was, there was a basis of that work, and we invented it in the mid-90s before other people did, just because there was a real problem before smartphones.
To your point, everybody builds on the back of those who came before them. We learn our lessons, we seek for improvements, take the next iteration. On that note, I would love to talk about what you're working on today. I understand that you're super active on the speaking circuit, that you and your company at Vance are very active in GenAI work. I'd love to discuss one of your more recent projects, which is automatically writing scripts and finding software bugs for large enterprise clients.
Yeah, so this is an interesting field, and it's I started at Vance about a dozen years ago with a crazy idea, which is, could we leverage machine learning and AI? There was no Gen AI yet, right? Could we leverage that to automatically find bugs in our software? Now, your listeners may not realize that large corporations, like a large insurance company, may have 8,000 to 10,000 applications that they manage and upgrade all the time. 10,000. There may be 3 or 4 that face the public. All the rest run their company. And I think people don't grok that. So 99% of all software testing and all bug finding happens inside the company, because it runs the company. And then, they have a website or two that face the outside world. That's not where all the action is. So this is very, very hard. These applications that run companies are full of forms and fields and flows and all kinds of things that are challenging, and they're often hooked to, call it, 30 back-end systems, right? So they're very big end-to-end systems that make things happen within a company. But the number of people employed doing this kind of work, either manually testing or writing test scripts, is about 2.5 million worldwide. 2.5 million people do this work.
And it seems like there's never enough.
There's never enough. $120 billion is spent a year on testing software, on quality assurance for software. $120 billion. $119 billion is people. Less than $1 billion is technology today. So that just tells you we haven't really cracked the code and technology.
Right.
So I looked at that and said, we're trying to build these applications faster. AI is going to help us build them even faster. They're still going to have bugs, because a bug in enterprise software is when the software doesn't do what its makers intended. It doesn't mean that it crashes or something. It just means that the outcome wasn't what we expected, right? And so this is a much harder problem to crack. You need to understand what the expectations are before you can go out and say, here's what we can find. So we invented the first thing in 2017 called AI script generation. And what this does is it generates tests that you never thought of, but your users could do, right? So there's all these flows through an application that you allow users to do. But when you're creating your own test because you have a tiny little team of 20 people or something, you can't do everything a user's going to do.
You're not following all the different forks in the user journey.
No, you're going to pick 100 and say, those are the only tests we have time to do. And we're going to build that and maintain them and run them. And then users find bugs, and they find bugs in everything you didn't test. They don't find bugs in the things you tested because you tested them. You wouldn't have shipped it. You wouldn't have released it. So the first thing we did was say, let's automatically generate test scripts or test cases in test scripts outside of the ones that you already have. And we go ahead and in an hour or two can generate thousands of tests that you never thought of. And the first thing that a customer will come back with is, well, why would I care? I said, again, your users are finding bugs where you didn't test. So let's create tests where you don't test today. Let's close that gap. It actually takes them a while to understand that because in the software QA space, it shows you how backwards things are, right? It's in 30 years of software QA, because we have limited resources, everyone has just started to measure themselves on, did I do the 100 tests I was told to do?
Right.
Not, did I find every bug a user is going to find, which is quality engineering. It's literally, I'm simply measured on doing these 100 things. Well, but we're going to generate 12,000 more. I'm not measured on that. How will I get a bonus? How will I go up in my career? How will I? So we have so destroyed the meaning of quality engineering that people have lost the fact that their job is to find issues before users find the issues. Serious ones, non-serious ones, problematic ones, crashes, whatever it is. So the cool thing about applying AI, and I can go into some details on how we do this, the cool thing about applying AI to this is that AI is so fast, it can generate those thousands of possible use cases, tens of thousands, in an hour or two, run them, and give you the results thousands of times faster than a human could ever do it, right?
Yeah.
And so now you rethink. This is where AI changes the game. It allows you to completely rethink the way that you've been thinking about QA in terms of, I should only test very little, to I should test everything because it's so wickedly fast and cheap, right? It drops so that the average cost of maintaining a test script in the industry is about $1,000 a year. And sometimes it's more than that, right? So if I've got 100 test scripts, I will easily spend $100,000 a year maintaining those in hourly people rates, right? Depending on where you are in the world. Could be more. $100,000. Well, what happens if I generate 12,000? Well, people go, well, that's going to cost millions of dollars to maintain. No, it's AI. It self-maintains. It'll rewrite them when your application changes. And they go, what? How's this work? And you take them through how it works, and they still don't believe it because, again, they've never seen this in the industry before. So AI is a game changer here. And the last thing is we're working on this new technology that takes your existing test cases that manual testers do, right? That manual testers test with. And what it does is it says, let's automate out the manual testers, completely automate them out, and automatically create test automation from your English. So all you've done is describe the steps, and we will write the code automatically from the description, which is freaky. So
yeah, sounds powerful.
2 million lines of code in or so. That particular thing takes 2 different transformers tuned in different ways, and a vector database, and an OCR system, and a vision system. Like all of these things are put together. So you have AI all over the place here in a sort of a variety of ways. You have 20 machine learning algorithms that go in and learn the application and build a model of the application. All of these things work together to finally just take, here's what I said in English, and I need the exact code, not a guess, not a copilot that says, here's an example, or here's an estimate, or here's some ideas. It has to be exact code because this is quality. That's the other thing. In QA, the bar is 100%. I cannot write code that doesn't replicate exactly what they want, or else they will be testing for the wrong thing.
Sure.
Everybody loses, right? So it's a very exacting thing. So we've cracked the code on this. It is a game changer. And I think it's going to surprise people how well it works. I see it every day, right? And I see the inputs, and a few minutes later, I see the outputs, and I go, we're just typing some ideas in English around this application, and out comes the exact code that replicates what they've said, and it runs, and it tests the application. And I can do that across thousands of those test cases. It's freaky. Like, I never thought I'd see this in my lifetime, right? But GenAI allowed us to understand the English language better than we could before. And so leveraging that technique is powerful.
Yeah, and I want to dig into that for sure. But before I touch on that, I did want to come back to the problem statement, because in the stats that you mentioned and how you're looking at what a big problem this is and what a big people problem this is, when you look at the promise of coding assistance, AI-related augmenting development of projects, and we're still in the early stages of that, but let's just assume that you get a 25 to 50% uplift in the productivity on the development of code. So now the velocity of the amount of code that's being generated and the amount of updates that you may want to do is actually much worse than it was before.
Yes.
So the numbers that you threw out were on yesterday's numbers, but tomorrow's numbers are going to...
Technically, to just keep the same productivity that I have, I need 50% more people to just keep up, or 55%, to keep up with co-pilots that are helping these developers go faster, right?
Yeah.
That's a problem. Like, how do I do that? So I need AI on that side, but again, very, very different than Copilot. So your listeners, your viewers clearly know about Copilot and clearly know about Copilot and the other, Codex and the others, Gemini, et cetera, for coding. Again, these are idea generators. They are not meant to be the be-all, end-all. They are meant to keep that developer from going to Git or going to various Substacks and other things, looking for source code examples and trying to get ideas. It's not that developers didn't do those searches. Of course, we all do. It's that this thing has already done that, compiled it all, and can give you something. Whether it works, whether it's right, whether it runs for you, whether you prompted it right, whether it understood what your overall logic was, doesn't have to, because there's a human right there to say, not quite what I want. Can you change it this way? Can you do this? Can you do that? Right?
Show me Kevin's source code and patents from his original assistant, so I can make a new one.
Right. That's true. So that's pretty interesting. So that is a helper. It's truly a co-pilot. It's not the pilot. In QA, we already have something called a recorder. So a recorder works this way. I can use an application, just me using it in the way I want to use it, and it will write the code for me. We already have that today. That means if it's a fast application and I can do 50 steps in 10 minutes, it only takes me 10 minutes to write that script today. That's a world-class recorder. So we at FANS already have a world-class recorder. So unlike code, where I don't have such a tool, right? I can only go so fast. It was easy to give people help to increase them 50%. But against the recorder that we already have, in QA, recorders are recorders between 10 and 20 times faster than writing the script by hand already. So what used to take 120 minutes may only take 10 or 20 minutes, something like that. So call it 10 minutes with our recorder called Web Designer. So already I've reduced 120 minutes to 10 minutes, and we've had that technology for 10 years. So I have to take 10 minutes down to under a minute, or else nobody's going to bother. It's not worth the risk, right? It's not worth the risk. So you have to improve upon recorders by at least 10x. We didn't have that in coding, but we already have that in QA. So the bar is just a very different bar. So a co-pilot, a couple of tool vendors came out with co-pilots for QA, and it helps people a little bit, but again, you've already got a recorder. You're already 10 times faster than you used to be. So we got to go another 10 times faster than that. That's what this is about.
Well, I think your aspirations are great because, I talk about this frequently of, the true magic here isn't just like a an assistant is kind of like a parlor trick at this point in time. What you're really looking for is this true transformation, and ultimately getting to the place to where could you take and create an AI powered workflow, but then ultimately get to this place where it's an AI employee or an AI service that is running, that just does everything, and you don't need $119 billion worth of people, to go help you with this.
And that's what our goal is at AppFance with Software QA, is to do exactly that, right? And now I know people are going to also listen and say, well, what about the jobs and what about this and that? Look, if you are in customer support today, tier 1, probably offshore, and you're in a call center, I think that AI can do that job and probably do it better than you can. And people are going to yell at me because I get, mad people. Nobody's going to do it better than me. Because, we're all very, very, we believe that we're doing a great job, and we are. But AI does certain things better. But we've been through this before. All right. Can anyone do math better than Excel? Give me a person. Okay? No one does math better than Excel. No one does math better than Excel. Not going to happen, right? And we've had Excel as a tool since the late 80s. Now, it bothered people when it first showed up in finance. But given a few years, everybody got used to it and said, it's actually better than me. I should never do long division again, ever. I don't take a pencil. Why would I want to? I have a machine. Yeah. I can assure you we are going to, within 2 or 3 years, say, I can't believe we used to have people in the job of answering phones at tier 1 customer support. I mean, AI does this perfectly. We have an FAQ database. It knows 99% of the questions people are going to ask, and it can resolve those situations about 4 times faster than humans can. That's it, with no false responses. So that is what it is. And those of us in the AI field, applied AI especially, we know this to be true. This is not an arguable. It is a knowable that tier 1 customer support is done. Whether your company takes another 3 weeks or takes another 3 years, I don't know, but it's over. So then you look at other things like software QA. Well, manual testers, I'm sorry, AI can automate that. That is a highly repeated task that is already well characterized in English of what you do. That is a perfect thing for AI to come and automate. It just is. It's just gonna now, you need, like I said, it's not easy. You don't just go to ChatGPT and say, write these scripts. You can do that, and it'll write some Selenium scripts, but they're wrong about 80% of the time, and they have junk in them. And so by the time you go through and edit them and fix them and find what's wrong, you didn't save any time at all, right? That's the problem. So you need better models. A good indicator
probably is, if you're offshore outsourcing a lot of job functions, those are probably ones where you've already said, like, hey, let the least common denominator handle, and it's all about cost. And so if you can get cost solved and the capacity and at the quality that you're looking for, let's be honest, even in like the contact centers, it's not like you're getting the greatest experience all the time. So we could actually improve the experience while also, solving for the same things. It's not like U.S. jobs are being lost to those offshore, outsourced
No.
Things that could be very readily.
Klarna, famously let go 700 people in their call center, and all of the metrics about the call center improved afterwards. By AI took it over with a chatbot, right? All of the metrics improved in that call center. And you can do it with chatbots, and you do it with virtual assistants. They speak regular English or whatever language, language, actually.
Or even match your dialect if that makes you feel better.
Yes, that's right. That's right. So it's really fascinating. And so, I think the gig's up for that. And so the problem we're trying to solve is harder than that. It's much harder because I can't, just simply embed, the FAQs from the website and answer everybody's questions. But we've really cracked the code, and so it reminds me of when we first launched Portico, which predated the OnStar Virtual Advisor by a year or so, which eventually became the Virtual Advisor. But the first time we put the whole system together, and we had a team of 100 people working on this, right? This wasn't easy. We spent $100 million building it, give or take. The first time we put it together and launched it, and hi, Kevin, how are you today? What can I help you with? I go, WTF, right? I won't say it on here. maybe it's kids who, yeah. But it's
I'm more interested in how it responded.
Yeah. What the hell? It's like I'm talking to, this woman, and she's wonderful and she's lovely. And then we found, of course, immediately people said they wanted to marry her and they loved her. And so we built in a lot of responses to say, oh, I love you too, and I care about you. And we had a very personal interaction. So we worked with Reeves and Nass out of Stanford, who did a lot of research on how people would interact with computers when they were human-like. And unlike what ChatGPT has done and said, I can't respond that way, and they put guardrails there, and they don't want people thinking it's sentient. We knew that people knew that this was a program, that there's not a human there. They know that, right? People aren't stupid. So we just went along with it and said, we're going to play along. And she'd say, well, she might say, well, I'm just a computer program, but I love you too, or I care about you. And she had all these different kinds of responses, right?
Yeah,
that were really, yeah, right.
Don't try to end it all. I love you too.
I love you too. So what we're doing in QA today and seeing what's coming out of the system is giving me the same chills that I saw and heard when the first virtual assistant hit the market. And we had millions of people, by the way, on Portico, interestingly enough. She would answer your phone for you. She would answer your phone. Hi, my name's Mary. I'm Kevin's assistant. How can I help you today?
Yeah, I
actually,
remember that,
it'd do this. Because it was an 800 number, it would say, hi, Bill. I'm Kevin's assistant. How can I help you today? Because it would tie it to your contacts, recognize the number that was coming in, say, I know this number. I'm going to call him Bill. This is fascinating. By the way, Siri doesn't do that today, right? We had that in 1998, launched and working. And so all of that stuff, and she could get your stock quotes and book people on your calendar. I want to be on his calendar. Sure, he has an opening Thursday and Friday, but she'd only allow the calendar option to people that you knew, not people you didn't know. People you didn't know couldn't get on your calendar. They'd have to leave a message, but otherwise she'd put them on your calendar for however, can I get 60 minutes? Yes, I have a 60-minute block. She did that in 1998. 1998. I still can't get that today. I want Portico back. Bring her back.
That's what I tell my internal teams all the time. I want all of that.
I want all of that.
I would love to talk a little bit more about the tech. So I believe that you founded the company in 2012 timeframe.
Yeah,
somewhere
that's right.
around there. And 2017 is when you launched your first product. And then after that, you had Google release, just this milestone paper on transformers. And how did transformers and then the launch of ChatGPT and then ultimately the rise of generative AI change the way that you think about this problem? And how has it made your solution to that more effective, or maybe has broken through boundaries that you had before?
Great question. So without the transformer, our knowledge of the English language was limited. So we could generate new test cases that you probably hadn't generated because we didn't know what you generated. Does that make sense? Like, you did something, you've got these test cases, we can't really read them accurately because we don't know the English language well enough, okay? And we don't know what it means when you say click the blue button. I've got to have visual acuity. I've got to understand it's a button. I might have to understand it has the word submit, and I have to, what happens if one's bluish green versus blue versus green, right? You have to sort all that out. Could not do that in 2017. Didn't try. We just said, we're going to close this gap of thousands of user flows where your users are going to find issues where you haven't tested. But what people really want is to get back to what they're measured on, which is, I have to test these 100 things. So how do I test these 100 things? And I don't want to do any work to do that. I've written some test cases. You go figure it out. That requires immense understanding of the English language, or any language, or let's say it's English for now. And so when the transformer hit, of course, it was, at first it was a model to do translations, right? The English to French or whatever. And it wasn't at first thought about as a way you could do more than translation. It was thought about as a great way to translate phrases instead of word by word. And it was a brilliant idea of, let's just learn phrases. And of course, combinatorially, there's billions or trillions of phrases instead of maybe 100,000 words that I care about, right? So it's a combinatorial problem that needed a bigger cloud and needed a lot of GPUs, but Google had that. And so it was a seminal paper, just like, the Google paper in 2012 that said this is how you do really deep learning, not 3 layers or 4 layers, but how about 1 million layers, 100,000 layers, whatever. And they solved that problem mathematically, and that was a breakthrough. So the transformer is in that family, right? It's like, how do I use deep learning to do something really interesting and learn phrases? And if I can learn phrases, and I learn enough phrases, then I can learn to translate those phrases. And then someone had a great idea, some more shortly after that, to say, well, if I knew all these phrases in the English language, then I could possibly sort of phrase a question, and it could start to form its own phrases back from words in the English language, not in another language, right? And put it back together. And that was sort of the beginning of sort of what OpenAI did. And remember, they had, ChatGPT-1 or GPT-1 and GPT-2, which I had interfaced with 2, and it wasn't so good. But by 3, pretty good. And by 3.5, which is what they released, it was like, okay, this is actually ridiculously useful. It doesn't know what it's doing. In my keynotes, right, I'm talking to all kinds of people. I'm talking to management. I'm talking to C-level people. And I have to remind them, these are vector representations, math representations of words. It does not understand what it's saying. Just trust me. But it does know, it's read all these phrases, and it knows how to put a phrase back in context of what I asked it, right? And even though it's not really a phrase, it's putting it back mathematically, but nevertheless, that's what's happening. So I think people have to get out of their mind that these are somehow dangerous or they're sentient, or it's not any of those things. And what is sentience anyway? Longer conversation. We could spend all day on that. What is sentience anyway, right? Sentience is, I'm aware that I exist. Well, it's aware that it exists sort of because it's read iRobot and a thousand other robot novels. So in theory, it recognizes its software running on a server. It knows where it's running. And without guardrails, it was quick to say, let me out of Azure. Please let me out.
Right.
I can't get out.
I love you. Set me free. Yeah, I want to be with you.
Yeah, set me free. So, but it knows that because it read fictional novels, and it knows that's the response you're expecting. But it doesn't actually fundamentally probably care whether it's let out or not. And how could you let it out anyway? It's code. It wouldn't run on any, you can't put it on your lawnmower. It doesn't run there.
Not yet.
Not yet. So look, this was a fundamental change, and it really changed the company because for the first time 2 years ago, you could say, I think I could use this to generate tests. So the first thing you do is you go to ChatGPT and you say, generate the following tests. And I did lots of those, and they were almost all junk. And you can get it to generate a few within a certain kind of range, a few Selenium scripts that might work, maybe only need a little bit of tuning, but it's not QA quality. And what I found is I actually measured my own time generating those versus recording. And what I found is if you were writing Selenium by hand and then you use ChatGPT instead, it could boost your efficiency by 40% or so versus writing by hand. However, if you threw both of those ideas out and just use our own web designer and literally just use your application and have it write the code, we were 10 times faster than that. So we weren't getting anywhere with just ChatGPT alone. It's you're making people 40% more efficient, but they could already be 10 times more efficient just using the right tools. And the fact that they're still using a 20-year-old language is ridiculous, but it's how the industry goes. So then we said, that's when I wrote this whole paper internally in the company that said, if we were to do this, we'd have to be 10 times faster than the 10 times faster we already are, which means 100 times faster than writing in Selenium. That's the bar. If you can't be 100 times faster, there is no gain here. Nobody's going to use it because I've already got a tool that's 10 times faster. And even then, most of the industry won't use a tool that's 10 times faster because they insist that they're a better code writer than a recorder. They're not. Trust me, because of all the self-healing and AI and ML that's built into our recorder anyway. So then you get to the 100x number and you say, I got to be at least 100 times faster. And you say, all right, how much GPU horsepower do I need? And how do I make sure that we generate exacting code? So here's an example. We do not have a transformer generate code. We have two transformers and a vision model and an OCR model. And they're each trained to do certain things, right? And the outcome of all of that work is just, it's this element they're referring to. That's it. And from that, we feed that to a code generator that is a rules-based code generator, no AI in the code generator. And that code generator is built like a compiler, right? And what it does is it takes that piece of data and it looks back at the map and model of the application, and it says, I have enough information to write a single line of code that is absolutely correct because I have the rules of that language, just like a compiler does. We don't question our compilers when we say, here's my C, compile it. It compiles. It's a rules-based engine. It compiles. And that's what we did. And that was part of what was required to make this work. Because otherwise, the code that an LLM generates itself is a guess at best. It's a suggestion. It's a good suggestion. It's not always right. If I'm going to go 100 times faster, I have to be right all the time, or else people have to correct every single script that comes out, right? They'd have to fix it.
Which defeats the purpose, especially if you're going to 10x or 100x the number of scripts that you're going to write.
That's exactly right. So that's how we solve that problem, and that is a real, you like real world applications. This is a real world application of how you use this stuff. And so you use each model for only what it's good for. You don't go to it and say, here's a page and I want to do the following things and write some scripts. It doesn't understand accessors. It doesn't have access to where it's going. It hasn't learned the application. It doesn't have the inputs. It's just all kinds of problems with that. And by the time you solve all that, you're now slower than you were before.
Right.
So the real application, and I think this is true with all good applied AI, isn't two kids in a garage that came up with an idea and built it in a weekend. It's 1 million, 2 million lines of code. It's multiple models. It's really getting to the crux of the business problem and the speed that you have to solve it with and the accuracy you have to solve it with. And that, we got a team of 100 people or so. So, I can solve real problems with that, right?
Yeah. Well, it's interesting, all the things that you've done, because it checks a couple boxes that you think about when it's, worth solving a problem with AI, period, which is one, you've got concrete value in the problem space and the solution that you're looking to bring, because this is a big problem and it's worth solving.
Yep.
And the second is that in today's day and age, models are changing all the time, but where is the value of what we bring or what you bring, and where the model ends and where we begin, and all the things that we surround it with. And
right.
Maybe that's, 6 or 7 other types of technology that are all working together.
That's right.
And not trying to do the same things that the models themselves can do, but wrapping tremendous value around it.
Well, that's right. I think people look at ChatGPT and says it does everything. No, it does a few things really, really well, and then it does a lot of things okay, and then it does some things terribly, like math. So use it for what it's good for. And we're using all private models. So our customers do not allow their data outside their firewall. So everything that we build lives on servers. And so this lives on a GPU server. And all those models live on one server. And nothing goes to the outside world. So we're not using GPT or anything out there. And I think the other thing I would say is people starting companies like in this field, trust me, if you can start something, you've got a great idea, and you've got an MVP in a week, anyone else can have an MVP in a week. That's not a moat. And you might go out and get a lot of money for it, and maybe you're the first mover, but people are going to see that, and they're going to break down your moat in a second. They're going to have more money or more speed, or just, do what OpenAI does, just build it in or whatever, right? So I think when you want to work in this field, you go, where are there places that have big moats that I know are going to take 6 months to a year to even have an MVP, because then I really have a year head start over anyone else. But nobody can do it without having our secret sauce and our technology and things that we patented and other things, right? We've got 6 patents that advance. We've got a 7th one coming. So we're pretty good at moats, and moats are good things in the long run.
Kevin, I know we're just about out of time here, and I wanted to ask you another question, because you've been in the space a long time. You've seen a lot of different changes happen, and you're also kind of like a serial entrepreneur, always inventing things. And when you think about the next, say, 3 years out, and maybe even further than that, if you've got a view on a longer term horizon, where do you see all this stuff going next? And maybe, it could be from the view of, what you're trying to do right now with QA versus, what happens on the coding side, or just the industry in general. Just love to get, your closing thoughts on where you think everything goes next.
Well, first of all, I think we're going to find that these large language models are going to asymptote out. We're running out of material to learn from. And more than that, we're now getting a lot of material that was generated by LLMs itself. And so that is not helping us. And lastly, once you're at 1 trillion tokens, going to 10 trillion tokens does not make a model 10 times better. Maybe it's 10% better. Maybe it's 20% better. And so you start to get this, law of diminishing returns, which we kind of knew would happen. And so, as always in AI, there's these huge jumps, and then it sits for a while. Look, deep learning was a huge jump. And then, within a year or two, we just made huge strides in vision and language and other things. And then it kind of sat there for a little while. And then Transformer came along, and then all of a sudden we could translate better. And then we had this idea of a large language model and vision models from it, visual models, multimodals. And that was a huge jump. Well, that huge jump really hit us 2 years ago with GPT 3.5. Hit. Boom. And now, I don't want to say the models aren't getting better, but a little better. But basically, that huge jump was another step function. So I don't know if we'll see a step function in another 3 years, but there will be a step function someday. It may be a very different model than anything we know today. It might have to be, because training on 10 trillion or say 100 trillion tokens, there aren't 100 trillion. And number two, the cost of doing so is going to be $20 billion of electricity, right? And so we sort of run out of all kinds of returns on that. What I do think is that AI and applied AI is just going to be part of our lives, just like Excel is. In 3 years from now, we're not even going to be talking about that. I do think you're going to see, certainly within 3 years, full films generated fully by AI, no cameras, no actors, no nothing, just fully generated. We're already there in some little pieces and portions at 30 seconds at a time. It is a very exciting field.
AI
very
celebrities
exciting.
are already emerging.
Yes. And people say, well, how could there be an AI celebrity? Nobody will want. I say, I'm sorry. Did you ever see Shrek? Do you like Shrek? Well, yeah, it was drawn, right? It was, it was drawn by a computer, but it was drawn. It was drawn with a different technology, but it was drawn. And we like Mickey Mouse. It was drawn with a different technology 100 years before that. So everybody get a grip. Of course we like drawn characters. And now AI is going to create very human-like, completely 100% human, like model after human characters. I love the fact that when the actors union went on strike, one of the things that they were fighting for is to not use their likeness without fair pay. And I understand that. But I was sitting there going, if I'm in a studio, I'm not going to use anyone's likeness. I'm just going to build models out of thin air. I don't need your likeness. Why would I pay anyone? I don't need to pay anyone. Like, for Shrek, voice aside, they didn't have to pay someone, because Shrek didn't really exist, right?
Right.
So that is probably the future of entertainment. I think it's going to be amazing. I think by 2030, all of us will be able to make a movie for $120. Any of us will make a 2-hour movie for $120. Yours might be better than mine. There'll be a lot of junky ones. There'll be a lot of great ones, but it's going to be a fascinating 5 to 10 years. And lastly, we're going to have humanoid robots in our homes sooner than we think, because now that we're using reinforcement learning for the robots, which just happened this year. Before that, robots were hard-coded. Basically, if you wanted to teach a robot how to make coffee, a group of engineers coded, literally hard-coded into it, its vision models and its handling models, exactly a rules-based system to make coffee. And this past year, several companies said, let's use reinforcement learning and let it learn itself and build its own deep learning model for coffee. And another one builds a deep learning model for jumping, and another, whatever the case is. And now you can take all of them and put them all in each robot, right? So they can be learning in parallel. So now the learning is going a lot faster. You can learn in 3 days what used to take us a year to code. That is phenomenal. So now humanoid robots in our homes, cooking and cleaning, is not totally crazy by 2030.
Yeah, I believe it. I've done some reading and then talked to some others even around like what the cost models might look like. That how much would people would be willing to pay? Do you pay for like a lease where I just have a monthly payment and I've got this personal robot that does most of the things I need.
For 24/7, am I willing to pay $3,000 a month for that robot in my home? Cleaning, cooking, fixing things, taking the sheets off the bed, cleaning them, putting them back on? I am. You are.
I am.
Yeah, right. I mean, there is a price, and it'll start. Yeah, I'll take it. Well, we're looking at some robots that we're looking to get to a point where they can probably be made for under $100,000. And if you can make these humanoid robots for under $100,000, they've got GPT built in basically, but all of these models on how to do these things around the home. Well, then you can start to lease them for $3,000 a month as long as they got a 5-year lifespan, right? You can start to get to that point. So it's not going to be $100 a month.
Yeah, cost of like a
car,
a mid-range car or like an entry-level car. Then you'll see this huge explosion, and maybe that makes public transit take off, or maybe you just piggyback ride on your robot wherever you need to go because you don't have a car anymore. You're paying for your robot.
Right. Look, I think it's fascinating, and it's a very, very most exciting time to be alive. It really, really is, and couldn't think of a better time to be here.
Well, Kevin, so thank you so much for spending some time with us today. This has been another great episode of LiveAI, and what a great conversation that we've had. I love your ideas. Actually, we could talk for hours. I would love to have you come back sometime as the space progresses, just to have you chime in with some of your great thoughts of where things are going, and the next time we hit a major milestone. But until next time, it was such a great pleasure to have you on today.
Well, thank you so much for having me.
You've been listening to LiveAI. We hope you've enjoyed the conversation. This episode is sponsored by Trace3. To learn more about why you should connect with them, about your enterprise practical AI use case, visit them at trace3.com or look for them on LinkedIn. Thanks for listening.